Hey students, welcome back. We are going to talk about free energy changes in chemical reactions. So basically we're going to be calculating delta G naught. So there's a couple of things that we can do here, but what we are doing first is defining. So delta G naught reaction, we're talking about the standard free energy of a reaction at the standard state. So we're talking about at our standard state of a reaction. Really pretty simple, pretty straightforward. All right. And so now what we have here is just taking and putting a reaction and a knot on each of those things. So instead of delta H equals, or delta G equals delta H minus T delta S, we're going to say delta G naught reaction equals delta H naught reaction minus T delta S naught reaction. That's kind of tough to say, but nonetheless, we've got that good to go. So what we've got to do there is we can do a couple of things there. So our first one is we're going to look at and calculate the delta G of that, right? Delta G naught, but we have to do that by calculating our delta H's and our delta S's. So remember when we find delta H and delta S's, we take products minus reactants times um, their either entropies or enthalpies. So we're going to use the back of the book and you can flip there and find it. So first we've got to find delta H. So I'm going to put delta H naught here of reaction. All right. And then in red, we'll do delta S naught of reaction. And then we'll plug it all together in green over here, delta G naught of reaction. But we've got a little work to get to before we get there. So let's start with delta H reaction. So remember, we're going to take products minus reactants. So let's just kind of look at that up here. Whether it be delta H or delta S, we're going to take 1 times whatever SO3 is, right? Minus 1 times whatever SO2 is, plus 1/2 of whatever O2 is as well. And that's going to be how we find both of them there. So let's do that for delta H. So we flip to the back and we see that SO3, the delta H naught of that is negative 395.7 minus, right? And then in brackets here, we've got 1 times whatever SO2 is, and SO2 is negative 296.8. And then we've got our oxygen, right? Plus 1/2 of, well, oxygen is going to be 0, right? Because it takes no energy to form that. So pretty simple there. We're going to have negative 395.7 plus 296.8, and that's going to give us our delta H naught, which is going to be negative. And we're going to get negative 98.9 kilojoules. All right. Now we're going to do that same thing with delta S, right? Same thing, looking it up in the same back of the book. So we're going to have 1 times whatever SO3 is, and SO3 is 256.8, minus 1 times whatever SO2 is, 248.2, plus 1/2 of whatever O2 is. And remember, this is going to have one because it talks about the amount of disorder, right? So we do all that. We've got 256.8, and then we're minus, we've got, if I can do math here, half of 205.2. We should get, I believe, 350.8. All right. And so that's negative, excuse me. So we'll put the negative sign on that. So we've got 256.8 minus 350.8, and we should get negative 94. Now, real quickly, remember that's joules per mole K, right? So let's go ahead and convert that to kilojoules since we're here, right? 0.094. That should be our kilojoules, and it's still negative per K. Now we're ready to plug this in over here, kind of blow this up a little bit and move over to the green side. And remember, our delta H or delta G naught reaction is equal to delta H naught reaction minus T delta S naught reaction. And we're ready to plug it in. So we've got our delta H is negative 98.9 minus our temp in our Kelvin, which is 298. And then we're going to times it by that 0.094, all right? Squishing it in there, but hopefully we're good. All right, so let's go ahead and do our math there. So it's going to be pretty negative, right? All right, so let's see what we got. Divided by 1,000. That's not 1,000. Okay. Times that by 298. We've got negative 28 there. And it should actually be, wasn't our delta S negative? So that's a negative, right? So that's positive 28.012. And then we've got negative 98.9. And so we're going to take negative 98.9 plus 28.012, and we should get negative 70.9 kilojoules, and there's our delta G. So we would definitely say that this is spontaneous, right? Because it's negative at room temperature, so or negative at this temperature, which is room temperature. All right, but it is spontaneous. So we're going to also say it is spontaneous. That's the other part of this question. It is spontaneous. Awesome, we got that. Now, there's another way we can do this. We can also tabulate delta G just like we calculated delta H and delta S. We can take our final minus our initial. And so that's what we're doing in this one. We're just going to take our products minus our reactants, just like we did with delta H and delta S in the previous problem. So let's make sure we've got that. We're going to look here at our items. So we've got products minus reactants. So we're going to take 2 times whatever H2O is, plus 4 times whatever O3 is. All right, that should be a bracket, minus 1 times whatever methane is, CH4, plus 8 times whatever. Wow, and I forgot CO2 on that other side. That might have happened earlier. All right, so we got that. Okay, let's go ahead and add a little CO2 in there. I think we can do that. We'll squish right there. Do a little erasing. All right, add this out front. We've got 1, whatever CO2 is. All right, and let's see what we got. So for CO2, looking it up, we've got negative 394.4 plus 2, whatever H2O is, negative 228.6 plus 4, whatever ozone is, 163.2. All right, that's all on the product side, minus whatever's on the reactant side. In this case, we've got methane, so we've got negative 50.5, and we've got plus 8 times 0. Well, that makes that math fairly easy right over here. So we're going to have plus 50.5, and let's see kind of what we get over here. We've got negative 394.4. We could obviously do all this together, but I like to practice the small calculations. So instead of plus, let's go ahead and make that a negative because it's going to be negative 457.2. And then we're going to have plus 4 times whatever 163.2 is. We get 652.8. All right, and let's just put this baby all together. And this is going to be delta H naught or delta G naught of a reaction. And this should come out to be we should get negative 148.3, and that's kilojoules. My dot got lost there, but there we are. So this is also spontaneous. Boop. Spontaneous because it's negative. Awesome. Now, another thing that we can do with delta G reaction is we can also use it like a Hess's Law problem, in which case that we can manipulate it like we would. And it makes sense because well, when we have more gasoline, we can get more energy, or I can drive farther in my car. So let's see how those rules kind of go. So if a chemical reaction is multiplied by the same factor, then delta G is also multiplied by that factor, right? All right. We also have, if it's reversed, then delta G is reversed. All right, so if it's positive one way, it's negative the other way. If a chemical reaction can be expressed in a series of steps, then delta G naught of reaction is the sum of those energies. All right, and we're going to see that down below in this last example we have here. So let's go ahead and see what we're getting. We're trying to get this reaction here. And we have these three reactions to kind of build to it. So let's look at that first one. What in that first one matches up with that top reaction? And hopefully you see C3H8, right? So, but we need it reversed to get that. So we're going to have -1 there. So when we reverse that reaction, it's going to look like 3 CO2 plus 4 H2Os gives us C3H8 and 5 O2s. And so our delta G naught reaction is going to be a positive 2074. All right, so that's our first one. That second one, if we look at it, we need that times 3 to get us 3 carbons. So we're going to times that whole thing by 3. And so we're going to get 3 carbon solids plus 3 O2 gases. And then we're going to get 3 CO2, obviously gases. And delta G naught of reaction is going to be 3 times negative 394.4. All right, and we're going to get negative 1,183.2 kilojoules. All right, and that last one, if we look at that, make sure we're on the right page there. We're going to need to multiply that baby by 2. All right, that gives us 4 H2s plus 2 O2s. And we're going to get 4 H2Os. And so delta G naught reaction is going to be equal to 2 times negative 457.1, and we should get negative 914.2. Let's just make sure real quick that we added these up and that they look all right. All right, and then we get our overall reaction that we're looking for. So we have 5 O2s here, and we have 3 and 2 there. That gives us 5. 3 CO2s. We want those to go bye-bye. 3 CO2s. 4 waters, and we should be left with what we're looking for. We got 3 C's plus 4 H2s, and we get C3H8. So now we can just add all those up and see if we get our correct answer there. So we got that one already plugged in. So let's go ahead and put and the answer I got is negative 23.4 kilojoules. Fairly simple, yes? Awesome. Well, that's the end of this video. Please read Why Free Energy is Free. That starts on page 877 and goes through 876 and ends on 877. See you next time.